Hello, everyone. Thanks for tuning in to this episode of the Software Plaza podcast. I'm Dwayne Taylor, editor at Software Plaza. And if you like what we discuss on this episode, go check out all of the other stuff we have on our website. We've got articles, we've got event coverage, job listings, and a lot more conversations like this. So definitely head there if this is something you're interested in. I'm quite excited for today's conversation. I have with me Alex Zenla, who is the co-founder and CTO at Edera. That's Edera. So you can go and check out their website at edera.dev. That's the website. And they're into security for containers and Kubernetes. And we'll get into more details about how exactly they approach container security in just a bit. But yeah, it's great to have you with us, Alex. And as we get started, I was just wondering if you can tell us a bit about yourself and just your path up to co-founding Edera.
Yeah, thanks for having me. I'm super excited to chat today. So yeah, my background is very non-traditional. I'm 25 years old, and I started in tech when I was 14 years old full time, and I was
Wow.
doing open source even before that when I was 11, something like that. So I've been a contributor to a bunch of open source projects. And what the catalyst to me getting into tech was actually Minecraft. I was heavily involved in the Minecraft community, and it kind of was a fun way to experiment with programming in a way that actually felt meaningful to me, especially at the time. I actually still do Minecraft stuff today, by the way. I've let it go throughout my career. But I got involved in the Internet of Things when that launched. Or I guess yeah, I was kind of in the middle of it. If you really look at the history of that, it's been going on for a long time. But I got hired overnight by a IoT company out in Oakland, California, and I've been doing IoT stuff ever since until last year. I spent 10 years in that industry. A lot of it was working with Google, and towards the end, almost exclusively with Google, doing Internet of Things stuff for their campus buildings. Some of it is even open source. And we had this pervasive problem of not having a good way to secure containers that were running at the edge. And I was really frustrated with the problem. There was no real great solution out there. And there's some unique challenges that come when you're doing edge devices. And nothing out there was really solving for it, particularly all the solutions that existed at the time required hardware virtualization, which wasn't always available on edge devices. As any developer might do, started working on it as a side project. And eventually it led me to creating what is now known as Adara Protect. And I found some lovely co-founders and we started Adara together. So that's how I ended up here.
All right. Wow, really interesting story. There are a lot of questions that I really want to ask. But to start
Yep.
off with, what do you think of the Minecraft movie? Did you like it or?
I haven't seen it yet, but I really want to. I think I might actually do that with some friends in the coming weeks. Uh, Minecraft is like embedded in my identity in a lot of ways. And in some way, because I was involved with it when it first came out, um, it's kind of wild to me that it's now a movie because I remember when it was just like this weird Java thing that someone made, and now it's, become a giant franchise. So
Yeah.
yeah,
Oh,
there's
amazing.
a lot of beauty, I think, in the story of Minecraft and actually how it relates to my life.
Mhm.
Um, a great example of that is Minecraft was eventually bought by Microsoft. And Adara is funded by M12, Microsoft's venture fund, which I always think is a
Oh,
very funny. funny
Oh, okay, cool.
combination of things.
Like, yeah, yeah. IoT and devices on the edge, they combine both hardware and software. And I was wondering, where do your interests lie? Is it more on the hardware side or more on the software side?
I've always been the person who's not, I won't say I'm great at hardware, but
Mm-hmm.
I understand hardware.
Mm-hmm.
And you kind of have to in part of the industry I was in. So, I was not in home IoT. I was in industrial IoT, which is kind of a different space in a lot of ways because you end up with like lots of serial devices and a bunch of older technology. So I had to understand things like power concepts and I worked a lot with electrical engineers. So I had a very, unique sense of like how hardware worked in that regard. Not so much on like silicon development or anything like that you see a lot in the home IoT space. Our target platform was often x86 industrial machines, basically just machines that are designed to, sit in an electrical room. Uh, but I think that my knowledge of hardware and especially of like old protocols and legacy technology really gave me so much insight into how we architected Adara because um, you know, uh, the software industry as a whole kind of moves so fast that people forget what happened 5 years ago. uh,
Mm-hmm.
I was talking to some people at KubeCon and they were telling me that like 5 years ago there were no security products for Kubernetes and now it's like all there is. Uh, and things just move so quickly in the software industry and IoT not at all. There's a protocol called Modbus that is was made in the 80s and is still used till this day on new builds of buildings. So yeah.
Wow. Yeah, yeah. You were talking about how while working on IoT, you realized that, there was just a lack of security and, for edge devices and something on those lines. Could you tell us a bit more about some of the exact moments some of the aha moments or when you realize, this is something I need to build, this is a need. Uh, could you trace the dots for us?
Yeah, so I had always known about containers since when they were fledgling, right? When LXC and everything was a thing. I guess it still is, but it's less popular now. When Docker came out, I was an early user, early adopter. Um, but there's containers were never really designed for what we're doing with them now. And the back in the day, it was basically a fancy cheroot. It was a, system. It was a system that was packaged up that you could just execute processes in. And that's basically all it still is. It uses these concepts called C groups and Linux namespaces. And there's then we've always had the history of virtual machines and the security, but also the flexibility that a lot of the virtual machine systems provided. And there was this graduation kind of from VMs to containers that I'm not sure was actually, you know, it was not, I guess, completely thought out. See, the user experience of containers was great. The user experience of building a VM image was horrible. And so you had this kind of DevOps people wanting to move towards containers because they're convenient, but you lose the security aspects of virtual machines. And I definitely had an aha moment when I realized that, containers could easily be placed in virtual machines securely. But the challenge with that is that virtual machines are these big, gigantic, bloated things in the typical sense, right? If you run a virtual machine today, It takes a lot of resources. If you've ever seen a system that's designed for running virtual machines at scale, it's usually gigantic, because you just need all these resources to do it. And my aha moment was realizing that if you changed how you run virtual machines and did it completely differently, you would be able to do it at scale and at the scale of containers. Um, and I am a computer history nerd. And I started looking into the history of virtualization. And what came up was, there were all sorts of things that happened in virtualization, going back to IBM and mainframes and partitioning, and then you have VMware, of course, and
And
um,
systems.
and mhm.
I was
And
saying microsystems.
yeah, yeah, exactly. Sun is a great example of like just crazy operating system development and doing, kind of interesting things with OSs, IBM as well. Um I but one thing stuck out to me. All of those systems have hardware designed for them, more or less. You look at IBM, you look at x86 virtualization with like KVM or VMware, or you look at Sun or any of these things. Uh, but there was one project that stuck out, and that was Zen. Zen was the hypervisor behind AWS. And the design of Zen predated the existence of virtualization extensions being available on CPUs today. Um, and it had a unique approach. Instead of virtualizing the x86 machine itself, creating software components in place of hardware components that would normally be there, it used para-virtualization. And paravirtualization is this technology that allows you to kind of basically it allows you to have the thing that you're virtualizing and the thing that virtualizes that thing both understand each other so they can ignore some of the details. If you are in the KVM world, VirtIO is an example of some form of paravirtualization on the IO and device side, but there's also virtualization or paravirtualization of like memory and CPU and that kind of thing. And Zen did that before I think anyone else really. And so I started looking into that and I realized like you can run containers on this really well because it's basically providing you a separate Linux kernel that is isolated away from the host system that's running containers or Kubernetes or whatever, but you can do it without, significant cost. You can run tens of thousands of these things on a machine, and you don't have to pay the cost of these giant virtual machines with QEMU and, all the other things that go along with that. And that was a moment where I just knew that I had to build something with this because I could not find it out there today, or I guess a year ago now, and so I started building it. I literally was up late at night after my job every day, just hacking away, and I didn't stop. I didn't know anything about hypervisors when I started this. I knew what I read in research papers, but I did not know what I was doing necessarily. And I learned so much in the span of a few weeks. And now I'm here with Edera building hypervisors as a company. So
Right. Wow. Yeah, really interesting that some of uh, those points you mentioned from, the history of computers, really fascinating.
yep.
Um, yeah, and I was wondering, as you were building, like writing the basic building blocks of Edera, what were some of the design decisions that you had to make? What were some of the considerations? What were you very sure that, this is something I absolutely want to focus on? And what are some things that you maybe were like, I'm okay to compromise with this, so long as we meet those higher priorities? Could you, um, yeah, could you talk to us a bit about just what was going through your mind as you were going through that whole process of building the product, the basic version?
Yeah, great question. So much was going through my head because there's so many things to balance. But I think the key thing was I really studied why people weren't doing this already. Because, in my mind, I'm a kid from Alabama. Like I'm, I never went to college. Surely someone's thought of this before. And the answer was, yeah, they have, but they took a different approach and they hit some major problems. There's a project out of Intel called Kata containers that some people who are listening to this are probably familiar with in this space. Um, and I was aware of it and I had actually used it before for my home lab, but I knew its limitations. And one of the things was the ease of use. Uh, Kata and a lot of the existing technologies like gvisor, for example, each had their own problems, but Kata's was ease of use and resource efficiency. Um, you could only run so many kata-based containers on a host because of the way the resource usage that it had. So I knew that we had to strip down and make things way lighter than anything that Kata had done before and also have more control over the system. There's a term in the space called trusted computing base, which means what's the smallest amount of code that you trust. And the TCB of Kata is gigantic. The TCB of Edera Protect is very small. That's primarily for resource efficiency and security. Um, the ease of use component, to me, this thing had to be a drop-in replacement, so transparent that you may not even realize you're running it. And that was really important because you're not going to migrate everything overnight, or just upgrade your security overnight unless you have a drop-in replacement that just works. And that includes allowing things that, I don't think this is the best security mechanism ever in Kubernetes, allowing, opting out of security features in order to make that ease of migration and gradual migration more possible. Um, for gvisor, which is another thing that's in this space, the security and the way they went about building gvisor had a number of concerns, but the biggest one was it was giant performance hit, 30% huge. And gvisor was not something that you could deploy across your entire cluster and just secure everything. So performance was extremely critical throughout this process. Um, I think with software, there's there's a lot of talk about the features you add to things, but not a lot about the features you leave out on purpose.
Mhm.
Um, and uh, and I think for us, it was we want to make sure there's not too many foot guns. Our goal is to be secured by default. So we have a kind of opt-out principle rather than an opt-in principle to security. So we have a container runtime called Styrolite that we built, which runs inside of our virtual machines that we call zones. And that provides, containers within the zone itself. And that has more secure defaults than anything you'll find in Docker. And I think that is extremely important that we uh, maintain good compatibility, but at least let you know when you are doing something that might be insecure.
Mm-hmm. Okay, okay, interesting. So in terms of like product market fit and like as you go to market, do you look at Edera as a replacement for Kata containers or gvisor? did you see it that way? And is that how it's positioned? And is that the kind of user base that you also look for to target? People already using these products, or is it broader than that?
Great question. It's twofold. We see some people that are using Kata and gvisor, but honestly, a majority of the people that we talk to have thought about it, maybe played with it in a development environment, but have never deployed it at scale.
Okay.
Primarily because the solutions that exist today just don't work for people.
Hmm.
Um, the gvisor, too high of a performance hit. Kata has its own performance hits as well as ease of use, and it's just hard to deploy and manage, especially when you have an environment that might have GPUs, for example, which is another thing that we're really good at. And providing security to GPUs is very important in today's day and age, and um, we just don't see people really deploying those things at scale. Um, we have heard many companies that have people who have tried. We've heard of many projects and companies where they're actively trying to deploy it, but it always takes way too long. And I think our market fit is strongly, tied to the fact that people know that they have insecurity in their containers today, and their solution to it is all these monitoring tools and observability. And we talked to some people who are literally deploying every security tool under the sun for Kubernetes. And I just don't think it should be that way. Um, and a lot of people that we talk to want to replace some portion of those tools. Instead of running every tool under the sun, you run one observability tool, and then you run Adara Protect, and you get security as just a benefit of being able to manage your infrastructure more efficiently. Um, the other thing that we see a lot is people spend more money to deal with the fact that containers are insecure, because the the common thing that we see is people will spin up separate Kubernetes clusters to run isolated workloads, as in, they have one customer and another customer. They will spin up one Kubernetes cluster per customer or things like that. Uh, this is very expensive because you're paying for the nodes more than once. Um, and you don't get to have the benefit of shared infrastructure which lowers costs. So if you deploy a Dara Protect and you can trust that lateral movement or privileged access can occur between two tenants because they're in isolated zones, then you don't have to pay for multiple nodes or giant sets of node pools on AWS or whatever it might be, because you can just deploy one set of nodes and trust that your containers will be secure. And I think that's another area where we're really finding people. The other one is AI clouds and those kinds of companies. Um, or anyone who's like reselling infrastructure. You put a credit card in on a website and you get a container back or whatever it might be. Um, those people really are interested in this because they have a huge risk in the security of their products, or the services they provide. But they also have this unique problem of they need to be able to manage resources effectively. If you buy a plan or whatever it may be, from, a provider. Let's say, you're hosting, some AI lab or something. You're probably buying a plan that has some set amount of memory, something like that. Um, Containers today don't really provide you the tools to limit the memory. They do, in the sense that you can limit the application memory. But if you have services that are feeding that, you can't really control the memory at scale. So, for example, the Linux kernel might have a whole bunch of memory allocated to service that container. is really hard to account for that. There's some attempts, but it's not deep enough. With our technology, you can get a really good sense of exactly how much energy, memory, and CPU you spent for delivering services to a particular customer. And that's extremely important, I think, for these clouds, as well as the GPU side of things, where GPUs are just not designed for multi-tenancy. So I think I saw a statistic that GPUs are usually at 60% utilization or something like that. With our technology, you can really divide up GPUs easier and give them to tenants, and your efficiency just goes through the roof because suddenly you're able to actually trust your infrastructure.
Interesting that you mentioned this example of vendors that provide AI backends as a service, and that they need a solution like this to isolate workloads. It completely makes sense, and the stakes are high there. But that makes me also wonder. Well, the people who've been doing something like this for the longest time is the hyperscalers, the big cloud
Yep.
vendors. And so they probably like thought through these challenges for a long time, really hard. And what have you skimmed through their solutions to see what they do, how they handle these issues? What do you find over there?
Great question. They do have some solutions. There's a few things that AWS has. AWS has Firecracker, which you can run, but Firecracker is not really designed to run containers. There's a project that lets you run containers with them. I think Kata actually supports Firecracker as well, but you still need to have bare metal systems on AWS, for example, and those are very costly and don't scale out as well. Our technology allows you to run micro VMs for isolation without the need for hardware virtualization. So you can run them on any AWS instance type. Somewhere I have the numbers, but I think we did a study that Firecracker runs on 9% of AWS instance types. Adera Protect runs on 95%. And so you can just adopt our technology across AWS instance types, bare metal or not. Even if you're already adopting bare metal and you want to keep that, we're happy with that. But if you want to save money and run on shared infrastructure, running on, smaller instance types, we can support that. Um, so uh, I guess the way I would put it is each cloud has their own way that they're trying to solve this. Google Cloud has gvisor. They have a button that you can click that just basically turns on gvisor for your entire cluster. But then you're going to pay so much more money because you need more nodes to support the fact that gvisor runs your stuff slower. Um, our one of our early employees, Jed, has a story where he worked at a startup where he was on the security team and was trying to get people to use gvisor because they had an insecure situation that they had developed where they were running customer workloads on the same infrastructure as their production infrastructure, which is very common, unfortunately. But gvisor had too much performance hit that they could not accept the cost of the cloud infrastructure that they would have to buy. You're talking 20% more cost, if not more, because of over provisioning. And I think the simplest way to put it, I think, is that public clouds and the hyperscalers want you to spend more money. And so any solutions that they develop for this are probably not going to give you the highest amount of efficiency. Whereas our solution kind of allows you to take back control of your infrastructure and get more out of it while also being secure. And I think that's the key differentiator there.
Wow, that's amazing. I mean, talk about your product supporting even more AWS services than AWS itself. That's quite
Yes,
on point.
it's a big difference. And we have a research paper related to this, and I believe we put the statistic in there, but If not, I'll make sure to add it. But
Mhm.
there's that number is striking to me.
Yeah.
95% of instance types, and I think we could probably get it to 100% if we looked a little closer.
Amazing. So yeah, we traced the background, the challenges, the solutions from different angles. I think we're ready to talk about Edera itself. Could you
Yeah.
describe it for us give us the elevator pitch?
Yeah, so Edera is a technology that you can deploy on a Kubernetes node, which provides a better, more secure platform that provides enhanced efficiency uh, and runs your containers inside of security zones that provide a enhanced layer of security while not requiring specific hardware virtualization. So we give you this additional concept in your Kubernetes node called zones. And zones, you can choose what you want them to be. You can make it so that by default, every Kubernetes pod runs in a zone. So we give you the most secure by default mechanism by default. Uh, you can install a Helm chart. You can run a installation script. Whatever you want to do, you can use our pre-built images. But once you deploy a Kubernetes node with these Edera protected nodes, uh, every container and every Kubernetes pod that you run is in an isolated zone. And that isolated zone prevents lateral movement and it prevents a number of other attacks like container escapes, all while balancing and managing the efficiency of resources across every container on the node. So you get precise control like memory ballooning, for example, in the VM space. We use memory ballooning and CPU adjustment to precisely schedule memory and CPU across your entire node. So you get more out of it. You can also set specific limits on resources. So for example, if you don't want tenant A to use more resources and starve the resources of tenant B, you can precisely set those policies inside Kubernetes. And we do all of this with just a single line of YAML on your Kubernetes pod. All you have to do is runtime class Edera. That's it. That is the interface that you have to Edera for you to just adopt it immediately. And if you're using an existing policy framework, you can even set it as a default runtime class so that everything that runs on that node runs in an isolated zone. So this technology is very, very important for people that want workload isolation, but it also is just a more secure way to run a container. It's the next generation container. Um, and we don't ship system D in our containers or in our zones rather. We don't ship any of the things that, typically something like Cather or gvisor would use. Instead, we run everything is written in Rust. So we have a Rust-based init that runs inside the zone and manages your containers for you. So uh, this is completely memory safe from top to bottom. We deploy a hypervisor that runs below the Linux kernel. So it's actually sitting far below it, and it's the first thing that boots on the node itself. And it ensures the security across all of the zones. So your host system is actually running in the zone itself. Um, but you won't know that because it'll just look like the same system that you're always used to, but it's virtualized itself, which gives you some really nice security and efficiency properties. Um, but that's the basic gist of how Adara Protect works. It's really easy to adopt. It provides really great security, and you just don't have to think about it. And you basically click a button and you're more secure.
Oh, really interesting. I've heard something similar a while back, but that was way back. I don't know if while you were looking through some of the history, if you came across this company, Giant, who was
Yes.
kind of doing. similar stuff about the time when containers came on the scene, and they had this product called Trident, which was again based on zones. And
Yes.
so it just reminded me of that. Really interesting
Yeah,
stuff.
yeah, no, it's very interesting. I do remember them. We came across a number of things in history where, people had gotten like 90% of the way there to what we're trying to achieve. But it never quite like there were some key missing pieces. The ease of deployment, that 95% to 9% statistic applies to almost every other person that was doing this, where they needed hardware virtualization. They needed the same things that Firecracker did. Um, and because we don't require that, you can just deploy this thing anywhere. And I think that's extremely like important, the key ingredient to this. I think it's why things never really caught on before anytime that other people have tried to adopt this, because I mean, just look at AWS. It's like, the most people are not using bare metal instances because you just can't scale with that. Um, and I think Joint would probably have required that if they were doing this. And so it's a huge key differentiator for us.
Interesting. I was wondering if you could give us a little glimpse of the architecture behind Edera and just how it's built. What are the different key components involved?
Yeah, absolutely. I have a diagram that I can share real quick.
Hmm.
Um, so I will share this right now. Can you see this?
Yep.
Awesome. So um, we have this is kind of a simple diagram here of how our infrastructure works. So when you boot up your system, it boots into the Edera hypervisor, which is a patched version of Zen. Zen is written in Misra C, so it's safety compliant. So it provides kind of the base layer of control of our system, does CPU and memory management. It doesn't really provide any of the drivers for the system. All it wants to do is manage CPU and memory and divide that out. From there, we have our root hardened zone, which is basically the standard operating system that you would run. One of the key things that we do with our product is we don't require you to run our operating system. You can just ship Amazon Linux, whatever distribution that you're currently using for Kubernetes, it's just going to work. You install this system on top of that. It's just a few Rust components. And from there, you're running Kubernetes, you're running Adara Protect, and Adara Protect can spin up other containers and run your customer applications or whatever you need inside of a hardened zone. So we have a number of things that we do on our zones. Um, we have something called open packs, which increases the security of the Linux kernel itself. But we also run each little thing in a virtual machine. So this root hardened zone as well is also a virtual machine. So you get to provide your own host operating system in Kubernetes. Whatever you want to run there, we're not changing the OS. We just install some extra components on it. And from there, each independent zone is spun up whenever you request a Kubernetes pod. We sit at the CRI level in Kubernetes, and we create a pod as a zone in Adara Protect. So every Kubernetes pod in your system becomes a Adara Protect zone. You can also, for example, say that I want a Kubernetes namespace to correspond to an Adara Protect zone. So, for example, if you want to put all of your tenants in a separate Kubernetes namespace, which to be clear, Kubernetes namespaces are not a security boundary, as I think everyone would tell you. Kubernetes namespaces are more or less, you can think of them just like a tag. They're all they do is tag something with a specific name. But we utilize that information, and if you want to, you can separate your zones by Kubernetes namespace, because it's a common thing that tenant ABC or whatever is a Kubernetes namespace. Um, so you can run all of those applications all in the same zone. So give you the same flexibility that Kubernetes would give you for running your pods, but we do this without hardware virtualization, without any specific requirements. When people talk about hypervisors, often people think, oh, it needs to run on bare metal or anything like that. It's not the case here. You can run this in Cumia if you want. You can run this in DigitalOcean or Linode or any place that you want. And it's just going to work. And that's extremely powerful, and allows you the flexibility and the dynamicness of the reality of infrastructure today. You can just trust that it's going to work. You don't have to have purpose-built hardware or anything like that. This Edera hypervisor sits below all of the other system or all of the virtual machines. Importantly, the hypervisor is not Linux itself. A very common thing that we get asked is, can I SSH into the hypervisor? And the answer is no. The hypervisor is 50,000 to 100,000 lines of code. It's not a Linux kernel. All it does is manages CPU and memory, and then it boots the next zone. That's all it does. If you have GPUs, you can connect the GPUs kind of sit inside the hypervisor here, and then they can be connected to each zone as you want them to be connected. We also have support for running uh, NVIDIA drivers and AMD drivers in a separate zone as well. So you don't even have to run them on the root zone, which increases the security of your system tenfold if you're using GPUs. So this technology is very, very flexible and allows you to do a lot of unique things with your platform and really trust the security, but also gives you enhanced efficiency.
Right. Wow. Interesting. And I see you really put a lot of thought into designing the product for making it AI ready,
Yep.
because that's definitely a lot of the focus these days. So it's great that you already, you're on the ball there. Um, I want to ask, as you use Edera, what are some of the metrics you'd see, or some of the alerts? What's like a usual day in working with Edera?
Great question. Because you can trust the security of the system since there's no lateral movement, executing or like having an attack in your system, which we still recommend using observability tools. We work with eBPF and existing tools out in the market. Um, you know, you can still get notified of any vulnerabilities, but you can trust that they don't spread. The best way that we like to describe it is that Adair Protect gives you context over the alerts you have. We've talked to people that have billions of alerts, literally, because they're running at such scale that anytime a process gets executed, suddenly there's an alert there. So we try to reduce that noise. But the cool thing that our platform does is we give you great observability of the resource usage of your system. So because we have these zones, we can see the memory and CPU that's being used, and we can directly attribute that to a zone. We can directly attribute that to a Kubernetes namespace. So we can give you perfect metrics. One of the cool things that we can do as well is we literally get CPU timing information. We know exactly how long a zone ran on a CPU down to the nanosecond. So we can calculate energy usage. We can calculate all these derived metrics that help you understand your infrastructure better. You can attribute now like the energy usage of a tenant directly, and I think that's extremely powerful. Um, so we like to be noiseless in the sense that we're not trying to raise alerts here and tell you that something's broken because we'd rather just secure it so it doesn't happen. With that said, we give you some escape hatches because the reality of the Kubernetes today is almost everyone is doing it insecurely. And if I just said, oh, I'm going to secure everything, and then locking out most people from being able to adopt, a more secure platform. But the cool thing is that you can do things that would normally be extremely insecure in Kubernetes, extremely securely in Adera Protect. For example, running with privileged mode in Kubernetes is extremely dangerous because you're basically just running a process on the host system with no isolation. You can do a container escape really easily with privileged mode. Privileged mode on the Dara Protect runs inside the zone. If you escape a zone, the only place you have to go to is the zone. You can't get to the root zone because it's not parented. It's a completely separate thing. And the trusted computing base of the Adara hypervisor means that it's so small, we can actually audit it really well for vulnerabilities. And so, you can really trust your infrastructure now. And you can do things, you can have, a DevOps team that has an exception to have privilege mode be true or whatever, which is a very common thing that we hear. Um, you can do that now without fear. I've literally talked to DevOps or security engineers who say that privilege mode in Kubernetes keeps them up at night because it's required for so many things. And now you can do that securely. And I think that's extremely critical for Kubernetes security.
Oh, right. Yeah. Isolation, the way it should be done.
Yeah.
We're out of time now, but I think the last question that I have for you, Alex, is just as you look ahead the next year or so, what are you building? I know your product is still, in its early stages. I'm sure there are a lot of big ideas you have, but give us a glimpse of what's ahead in the next year or so for Adira.
Yeah, absolutely. So we have an existing feature that I think will blow people's minds when I say this, but you can literally migrate a container from one host to the other while it's running. Um, and that's extremely powerful, but I want to get even further into that. So I think we'll be doing more with that in the future. Imagine being able to migrate an entire Kubernetes host worth of containers to a different host with a click of a button. My favorite example of this is, oh, your container got compromised. Well, just move it to a different host so you can quarantine it. That's a great example of something that that we want to be able to do. Uh, we call that the introspectability that you get, that you can actually, trust, that you can isolate something. So if you get compromised, you can actually deal with that well, and quarantine things. But I think the thing that most excites me, honestly, is working with new types of hardware like GPUs or TPUs or DPUs or any of the various things that people want to connect over PCIe or whatever it might be. As a nerd, that stuff excites me the most, and we have so much happening in that space. GPUs today are kind of a security nightmare. I think anyone who's listening to this who works with GPUs on Kubernetes today probably knows that you have to disable basically every security thing that you have in order to use a GPU. And that's just unacceptable, really. GPUs are effectively another computer inside of your machine. So we need to think about security differently for them. And we have some cool things coming out on our roadmap that I think will blow people's minds, but also more importantly than being cool and flashy, actually help people. And that's why I'm in this, is to fix it. I'm tired of insecurity in the industry. I just want things to be secure and also efficient. And so yeah, I'm as you know, as you probably can tell, I'm very excited about our roadmap. So
Yeah, yeah, yeah. Sounds exciting. And you should come back and talk to us about it when you launch some of those features. We'd love to have you back. Last
absolutely, I'd love to.
Yeah, last question before we end, Alex, is just to get to know you a bit. what would you be doing if not for your job in tech right now? What would be your alternate career path?
Yeah, this is a great question. I have many options because I'm one of those people that I like history and I like I love space stuff and I love rocketry. Um, if I ever retire from this industry, I might go do rocketry of some sort. Rocket science is super cool, and physics is super cool. But probably a more realistic answer
Mhm.
uh, is I really love teaching people computer history. Um, and I did not go to college. I dropped out of college one semester in because I was already working in tech at that point.
Mhm.
And you know, I see a lot of engineers who know a lot about like how to make a web app or how to make a web backend or something like that. And that's important because that's how you make money in the real world. But I think there's a certain beauty of binding software engineering with computer history and computer science that some people miss out on. And I feel like that greatly helped to my experience at Edera. You know, as you've seen from the design, I took some ideas from computer history. So I recommend anyone who is interested in computer history to just never stop learning because it always gets more interesting. And something that I learned recently is like people that you hear that invented things in the last 20 years, you can just email them and ask them to talk to you. I've done that a few times. Um, so yeah, that would be what I would want to do is like computer science professor or something like that. Because I would approach it differently, I think, than most.
Yeah, yeah. Well, I think that's definitely needed, and I think seeing how passionate you are about it, I think you'll make a great advocate for that. It was a pleasure chatting with you today, Alex. Thanks for coming on the podcast. Thanks for telling us about Adira and just your journey. It's really exciting to see. Do come back again and tell us when you launch more new stuff, new cool stuff. Would love to talk about it. Was genuinely a blast chatting with you today.
Awesome. Thank you so much. Thanks for having me. This is great.
And thanks to all of our listeners and viewers for tuning in. We hope you found this one as exciting as we did, bringing it to you. And we hope to see you on the next episode. Take care then. Bye bye.